Assalamu alaikum, grade 6. Welcome again to the physics session. Today, inshallah, we're going to start lesson number 4, and this is chapter number 3. And actually, this is the end of your curriculum here in our course group. And the lesson for today, the last lesson. And the title for today, lesson 4, that's talking about the putting machines together. Putting machines together. You can remember in this chapter we talking about the work and machines. Lesson number 1, we talking about the work and power, and lesson number 2, understanding the machines and how work machines. Lesson number 3, we talking about the examples of simple machines, and today lesson 4, we talking about how can make compounds between the simple machines and how this is work. And the big questions for today, number 1, that's talking about the what simple machines make use of turning. So what is the tools we can use it for turning? At what's the meaning of turning? Question number 2, or point number 2, we're talking about today, inshallah, how does a compound machine work? How can make the compound between some examples of simple machines and how that can make work easier. Now, before going to open our lesson today, we can watching this video that give you some examples of simple machines and how that's working together. Now we can go into the opener of our lesson today. The opener for our lesson today that's talking about ladder alert. Ladder alert, that's technology that's using by some sailors to find the locations in the sea. So sailors needs to know wind speed and direction to position their sails. But that using some technology here by some stations called ladder alert with the information they gather from this new ladder stations that using another tools like the simple machines, and that's helping them for use that to control their sails. And sailors can gradually improve their changes of navigation safely and the winning racing. So here you can watching some examples of simple machines that working together to make the sails easily or make the navigation safely. And this is examples of simple machines like pulley, such as movable pulley or fixed pulley. And actually that's helping sailors to make the navigation easily and moving and winning the races. So this is the opener of our lesson today, and that's talk about helping the sailors by simple machines to make the sail easily and they make the work or controlling the speed of the wind and direction of the wind. Now we can go in to start our lesson today by point number 1. And question number 1 today, that's talking about what simple machines make use of turning. And actually this is question we can divide it to 2 questions. Number 1, how a pulley work and how the wheel and axle work. In the beginning, in this question, the pulley and wheel wheel and axle are two examples of simple machines, and that's take advantage of turning. Actually, what's the meaning of turning? And that's talking about the pulling something or get some objects in water or pulling by gravity. Actually, question number one in this is point that's talking about how a pulley works. A pulley is a example of simple machines that's made up of a grooved wheel with a rod or cable wrapped around it. You can watch it or see that called pulley. And we have different kinds of pulley. Actually, a pulley can make work easier. By what? By decreasing the amount of input force needed to lift the object. We can use it in some port, and that's to get the heavy objects from the ground to up, and that can make the work easier. And that's make the work easier by decreasing the amount of input force here by this direction, and to lift the objects from the ground, and changing the direction of input force. So this is input force in this is direction, and we have output force in this is direction. Actually, the ideal mechanical advantage, and you can remember what's the meaning of mechanical advantage. We learned it before that. The mechanical advantage, that's meaning the ratio between the input force and the output force. Here, ideal mechanical advantage of a pulley is equal the number of sections of rope that support the object. And we have here different kinds of pulley. Now we can talk about the types of pulleys. Number one, we have three kinds of pulleys. Number one, fixed pulley, movable pulley, and block and tackle. So number one, fixed pulley, that's the pulley that's fixed in the same point, and the rope that's moving around the pulley. So that's fixed in this is point. And we have here the direction of input, opposite direction of the output force. So this is type number one of pulley, fixed pulley. Number two, movable pulley, and that this difference kind between this is type and this is type. Here, pulley that's movable in movement, not stable in the same position. And here, the direction of input just like of direction of output force, and here that just change the amount of the force, the input force and the output force. So the difference here, the pulley that's movable, not staying or fixed in the same point, but in different position. If we get the input force in this direction, we have changing the position of the pole, and this is kind number two. Number three, block and tackle, that's containing two kinds of pulleys. Number one, fixed and movable. So this is type that's containing two kinds of pulleys. Number one, fixed and movable. Number one, fixed pulley, and number two, movable pulley. And here we have difference in direction and the amount of input force and output force. Now we can talking about each one of them. Number one, fixed pulley. It's attached to this is a structure, and that only change the direction of force. So here, fixed point, Here fixed point we can find the fixed pulley. We have the different direction of input and output force, and we can calculate the mechanical advantage here for fixed pulley, and that's equal 1. So the main point here, that's the direction. Change only the direction of force from input to output. Input in this direction and output in this direction, but not change any amount of force between the output force and input force. Just change the direction. So this is number one. When I get something or object by the type of number one of poles, then fix it. That's fixed in the same place. That's not changing the position of this is pulley, and actually that changed the direction, only the direction of input and output force, and that's mechanical advantage equal 1. This is type number 1. Now talking about the type number 2, the movable pulley, and that's attached directly to the object P being moved. So this is state in move, and that only decreases the amount of input force needed. Movable pulley here, we can describe it by not changing the direction, but they change the amount of input force needed. So here, that's pulley in motion, that's changing the position, not just like the fixed. And here we can put the object from the ground by decreases the amount of input and between it and the output force. This is kind number 1 and number 2 of poles. And mechanical advantage we can calculate here with 2, that's equal 2. Why? Because that decreases the amount of input force. So this is the direction of input force, and this is direction of output force, and actually this is the same direction, but the difference in amount of the force between that decreases the input force needed to pull this is object up the ground. Excellent. Now we can go into the point number 3, and that's talking about the pulley or pulleys, and it decreases the amount of input force needed and may change the direction of force. So here the kind number 3 of pulleys, that's made up of two pulleys, number 1 fixed and number 2 movable, and that's change the direction and the amount, direction of input force and output force, and the direction and the amount of force. And we can calculate the mechanical advantage here with 3, that's equal 3. You can watch in this video, let's give you example about the kind number 3 pole and circle. That's made up of 2 poles, number 1 fixed, number 2 movable, and that's pole, this is object in the ground up, and the changing of direction between the input force and output force, and change the amount of forces needed by input force. Now all of you know what the 3 types of pulleys and the difference between them. Now we can go into the point number 2, and this is question number 1, and that's talking about how a wheel and axle work, how a wheel and axle work, and actually what's the meaning of wheel and axle, and that's how that's making the work easier. Actually here we can watching this is figure that's talking about the axle and wheel. A wheel and axle that's made up of two connected objects that turn a common attached axis. So that's turning around their axis. And this is here we for this is work we have important rules. So we have here output force and input force. Input force in this direction and this is output in this direction. You can observe this is in the same direction. But what's happening here for the amount of force between input and output force? Actually, this is the axle, that's meaning the object number one. Number two, the wheel. And we have something called radius. Radius that have of diameter of this is wheel or the diameter of this is axle. Actually, what's the meaning of that or how we can use it? This is radius for what? If you apply input force to the wheel, the axle exerts a large output force over a shorter distance. And if you apply input force to the axle, the wheel exerts a smaller output force over the greater distance. So we have here difference between the amount of force that's taken by the wheel or axle and the distance of force. So number one, or let's take number one here, input force. When the input force larger, output force can make the here in the wheel. When I put force larger in the wheel, we can find large force here in output in axle. But the difference kind when I put input force in the axle, that's found the wheel smaller force. So we can watching the difference between them. So this is can make the imagine about the movable of wheel when movable of axle. So when I go the wheel input force, we can find large output force in short distance. But here the difference kind when I put force here or input here in the axle, that we can find the greater distance and smaller output force, and we can make imagine about the difference between these two states of wheel and axle works. Now we can go in to calculate the mechanical advantage. How we can calculate the ideal mechanical advantage here between the output force and input force in wheel and axle. Actually, we can using the radius. Radius that's equal the half of diameter of axle or wheel. And the radius of the wheel divided by the radius of the axle, we can find the mechanical advantage. And it's greater if the ratio between them, between the wheel radius and the axle wheels larger. So when the ratio between them equal larger, we can calculate the original amount of mechanical advantage. So mechanical advantage MA here we can find it in the wheel or axle by divided between the radius of wheel and the radius of axle. If the amount of this is number higher or larger, we can find mechanical advantage larger. So again, we can find ideal mechanical advantage for wheel and axle between the ratio between the radius of wheel, that's meaning the half distance between the center of the wheel and the circle of the wheel, and the radius of the axle, that's the distance between the center of the wheel and the circle of the axle and the circle of the axle. And actually the radius that equal the half of diameter of wheel or axle. And the ratio between them, divided the ratio between the wheel and the ratio about the axle, we can find the mechanical or ideal mechanical advantage. Now, we can go in point number 2 in our lesson today. And that's talking about how does compounds or make compounds between machines or simple machines to work. And this is compounds to work. Actually, who can tell me what is this device called? Yes, that's called Movable Pulley. So a compound machines that combines two or more simple machines together in a single machine that make the work easier, like here in the Movable Pulley. For example, an apple peeler consists of three simple machines. Number one, wedge. We taken the wedge in the last session and how the wedge that's tool for simple machines and how that work. And screw and wheel and axle. And you can see here the wedge here that can make the divided for this is an apple, and the screw and wheel and axle. Actually, how this is command for simple machines work together. You can see here how this is work or how this is simple machines work, and that consists of four kinds of simple machines: wedge and screw, wheel and axle. The output force here in one simple machine becomes in the input force. So here we can know how this work. That work because every one of the simple machines output for another simple machines. So the output of one simple machines become the input of another one of another simple machines. And we can calculate it here the ideal mechanical advantage by multiplying. So the ideal mechanical advantage here of compound of machines like this by multiplying the ideal mechanical advantage for the simple machines together to make the multiplying between the wedge, screw and wheel and axle. Each one of them have ideal mechanical advantage. So we can make a multiplying together for all these machines to make or to find the mechanical advantage for the compound of machine. Actually, this is the end of our lesson today. I hope you understand me and you can make revise for this lesson. And that's talking about the some machines or simple machines working together to make a single machines like this is Movable Pulley. I hope you understand our curriculum for our quarter and study well. Any question you can send me in WhatsApp, and please again and again answer your worksheets and send me in WhatsApp. Anytime, I'm available anytime. Thank you for listening, grade 6, and goodbye.